Okay, I think it's streaming live on YouTube now. Great. I can see myself. Okay, cool. How's everyone doing? I can't really hear anyone, but I'm assuming that that's a good sign. Everyone's doing well. How's the homework? Easy, hard, too much, too little? You want more? For those of you who attempted it.
It was a bit tough, but I mean, then again, I was doing it while I was watching TV, so I don't know.
Okay. Uh,
The chess
I think
questions
that
trip
was
me up.
good.
sorry?
Oh, I thought the homework was good.
The chess questions
No.
trip me up.
Yeah, I get that.
Yeah,
Okay,
The only
yeah.
thing I didn't get was the last question because it was worded so weirdly. I just had no idea what it was even asking me.
I didn't really understand the chess questions or the lace question.
The chess question, it was literally just if it's a legal move or not.
Yeah, I don't play chess that much, so I don't know. I like a lot about it. So,
Uh,
and no
yeah.
one in my no one in my family also plays chess a lot. So,
Okay. Yeah, that's there's no worries. Yeah, it's tricky because sometimes you're asked to, put yourself into like word problems where like, maybe a little bit of background knowledge would help, but it's not necessarily problem in the homework or in the classwork twice yesterday, and I skipped the second occurrence. I think people were proposing basically this solution, which was kind of what was intended for the second version of the problem, but there's another thing that we could do, which is um well, let's not get to I think something like that right now, too complicated, but there are basically, I guess, just fancier ways of being able to use things like this, conditions in order to switch what's executed. Um, but let me get to that later. I don't want to actually overwhelm you guys with too much knowledge right now, but let's start with the Fibonacci sequence. So I know that yesterday Evan had proposed like, hey, why don't we just use the Benet's formula? So do you want to share what you put for that, Evan?
Sure. Uh, should I just sure? Which that was problem 13, right?
Yeah.
I said from math import square root, and and number of terms I said is it's the integer value of the input. So int of input of a prompt to the user that says enter the number of terms. So it's given by the user. And then I said for n in range, 1 to the number of terms plus 1, number of terms plus 1, which is a variable defined above. I said print int of, so the floor of 1 plus square root of 5 all over 2 to the n minus 1 minus square root of 5 over 2 all to the n divided by square root of 5. And that just uses Benet's formula, and then it keeps going over all the terms.
Yes.
And in that range.
Let me actually one thing I want to mention before we go there. Um, I don't know how experienced you guys are with like libraries or importing code or modules. Um, Different programming languages may call it different things, but the idea is that you don't need to recreate everything from scratch, right? Some people have created, working implementations of common functions or pieces of code that other people will need to use. And so you will use what are called libraries of code. Like for example, the math library, right? That has different things implemented like the square root or ceiling or floor functions. And oftentimes these are highly optimized and written in a way that might be difficult for us to write because there's only so, much optimization you can do within Python. But maybe that implementation of the square root formula is actually written in C, which is a faster language. So anyway, if you want to import things, you can do it in two ways. One is you import the entire library, which is import math. And then if you want to call anything from the library, you will call it by saying math.square-root or math.floor. Math.floor. And then if you want to import a specific function from that library or specific value like pi, specific constant, you can do it using this notation, which is from math import square root floor pi. And then if you want to access it, you can do so by just calling the square root function, or floor function, or pi function. Or not pi function, but pi constant. Does that make sense? This notation? Okay. And then and so sorry, you were saying I was 1 plus square root of 5 over 2, right? But let me backtrack a second.
One plus square root of 5 over 2 raised to the power of n. So 2 asterisks. Yeah, okay. Minus 1 minus square root of 5 over 2, also raised to the I. Parentheses over around that. And then also raised to the I. And then divide the whole thing by square root of 5. And then take integer value that is for some reason it was having like 3.00. It was saying like 3.0000 something. So it's say int or mass floor. Okay, yeah.
Okay. So let's say
Yeah, and that should give you Fibonacci numbers. I think you might have to add one to the I don't know.
let's
So
start.
I had in range 1 through fib number of IDX plus 1 because this formula gives you that the 0th Fibonacci number is 0. So what happened?
Okay, yeah, you're right. So this is
Okay, so it's gonna give you 0 as your first number. And you need to have the thing entered plus 1, I think.
Yeah, I think this looks pretty good. We can be more specific and say oops. Okay, I think I've gotten lost with the number of parentheses I have somehow. Okay, is that right? No. Anyone know what's going on with my parentheses? Let's see.
If someone has a working solution, you can copy paste it in the chat. And that's an easy way to fix it.
Okay. Well, okay, you guys get the point though, right? I just can't figure out where to terminate my parentheses because of how many I have. No. Interesting. Okay. Okay. First. Well, we'll ignore that is printing out the fifth Fibonacci number is 5. But yeah, okay, I think this works. Okay, we have some interesting solutions inside the chat. Jacob, let me see if I can paste yours inside of here. No, I can't. Okay, well, I'll type it out. Okay, so you've done basically the same thing and said, hey, give me, this input as like enter the number of terms you want. Then num1 equals 0, num2 equals 1, next number equals num2, count equals 1, while count is less than or equal to n, print next number, and n equals to count plus equals 1, num1 comma num2 equals to num2 comma next number. Ooh, this is very cool. Okay, next number equals to num1 plus num2, and I assume you want me to print out next number here, and we should also probably just print out num2 here. Or no, you already print out next number here, but I see. But we should probably print out at the end, right? Or should we? 5. Okay, 1, 2, 3, 4, 5. 3. Oh, guys, do this 5 times. Okay. Oh, okay. Actually, this should work. I don't. You're just doing things at the end. Okay, let's try this. Yeah, that's probably because I changed the name. Okay, so I have a lot of questions. First of all, Jacob, how did you discover this n equals quotation mark?
I may or may not have enlisted the help of other outside sources.
Mm-hmm. That's what I thought. Okay.
I wrote most of it. It's just I didn't know how to put that space. So I looked up how to get the n equals thing.
I see. Okay. Oh, and you do have a space inside of your quote here. I did not copy that correctly, but okay, cool. So let me say a few things about this. What's going on here? Okay, so num1 equals 0, num2 equals 1. And then we have this interesting thing where he's using this kind of temp variable, next number equals to num2. And the reason why is he's using it to basically figure out what to print next, which is always num2. And then it's a little more convenient for him to be able to exchange the previous 2 values of the Fibonacci number sequence with the next 2. So the next 2 basically replace the previous 2. So this is num2, and technically this is num2 as well right now, right? But at the start. But then it becomes num1 plus num2, right? And so then we have so let's write out what happens the first iteration. So num1 is 0, num2 is 1, next number is 1. So then when we go through the while loop, it says num1 comma num2 equals to 0 comma 1, right? And then next number equals to 0 plus 1, so it's equal to 1. Okay, cool. So now the second time we go to the iteration, or iterate through this while loop, we say num1 comma num2 equals 1 comma 1. And so next number is equal to 2. Third time it's num1 comma num2 equals to 1 comma 2. Next number equals to 2. So I want to explain this syntax a little more because, okay, usually in other programming language, and by the way, did you discover this syntax yourself, Jacob?
Yeah, when I was studying for it on W2 schools, I learned that.
Okay, nice. Okay, good. Very nice. Okay, so this is more of that syntactic sugar I was talking about yesterday, right? Like fancy notation that helps you do cool things. Sometimes write things in a more compact way. So let's say I have variables a equals 7, b equals 5, right? If I want to swap the values of a and b, usually in most languages, what you have to do is say something like, well, okay, I want A to equal B, but if I do that, I lose the value of A. So let me actually save what the value of A was inside of a temp variable. So temp equals A equals B, and now B can take on the value of A that it was originally by saying B equals temp. So you have to enlist the help of a temp variable. Does that make sense? But here, what we actually do is we instead of enlisting the help of a temp variable, we just say A comma B equals B comma A in Python. You can just do this, and what happens under the hood is B comma A is a tuple. It gets formed into a tuple. And then we say, hey, that tuple, that has two elements. I want you to store those two elements inside of these two variables. So it unwraps the tuple. Unwraps means like, just kind of wraps the parentheses, right? And it assigns the values of 7 and 5 to B and A. So let me make this more explicit. So if I say B comma A, right, under the hood, that might get transformed to something like this, 5 comma 7, right? And then if I say A comma B equals to 5 comma 7, this is equivalent to me saying A equals 5, B equals 7, right? Because there's two elements. I'm assigning two variables to hold the value of two elements. So A equals 5, B equals 7. Does it make sense what this notation means? A comma B equals B comma A. And this is what Jacob used to his advantage to kind of avoid making this maybe look too complicated. So the next two variables to take over the values of the previous two variables. Does that make sense to everyone? Okay, cool. And then count equals 1. Yeah, he's just incrementing it to make sure that like we don't exceed the number of Fibonacci numbers we requested. The more parallel your code is, like, if you're repeating stuff like over here, next number equals num2, right? I like to keep my code as parallel as possible to avoid mistakes and edge cases. So I would write num1 plus num2 here because 4 and 10 that way they match. Now, in your case, 10 is actually in line 4, num1 is 0, right? So it ends up becoming equivalent to saying this is equal to num2, right? But I just wanted to say equals num1 plus num2 to have that similarity. Now that we have that similarity, what we can also do is say like, okay, next number equals to num1 plus num2. Why should I ever make this, a special case? Why don't I just take care of this inside of this while loop, when I'm already taking care of it here? So I should move it down here. But that means that I have to change around the logic because next number is not defined for the first iteration of this. So the way I make sure it's defined is I would print it out here once I have the value of next number, and I do this to make sure then we exchange the values after, again, next number is defined, right? And then count equals plus 1. Count equals 1. We start off with, let's say, count equals 0 instead. Is that right? No, that's not right. Yeah, we can still start with count equals 1. Because we're going through all of the same number of times. So let me, yeah. So 1, 2, 3, 5, 8. Does that make sense? How it's the same thing? Yeah. Okay. Now, again, if you want to make this even a little, normal, like notation compared to like, what we normally do, which is we start at 0, right? And instead of going into less or equals to n, we go to less than n. We might use notation like this, right? And now what's interesting here is we actually don't even care about necessarily needing a while loop, right? It's not that like, so while loops are helpful when some certain condition needs to be met, but if that certain condition is just a counter variable, we could use a for loop. So this is good, but we could also just do something like for I in range of n. And that way, I don't have to, monitor count. I don't have to keep track of count or think about it. I can just do this, right? And so this will automatically ensure that this for loop is executed n times, right? And so this works. And then what else can we do? So we could let's just stop there. Actually, this is getting fun. But something I want to mention. So Jacob was like, "Hey, I want to print everything out on the same line. How come I can't?" It's because print always adds a /n character at the end. So now let's look at the print function. Let's look up the syntax for it. Let's look at all the is it in here? Let's see. Let's look at the arguments it takes. So in this case, it can take, a few different objects. So that's why we can put in a lot of things separated by commas. But then if you want to specifically change one of these, you have to call them out by name. And we haven't quite gotten to functions yet, so I know this is a little maybe and fancier than we have done before. But essentially, there's different arguments that can be passed into a function, and you can either name them or you cannot. You could say just like, print a comma b, and it knows that, okay, well, if you pass this into me, it's for the intention of printing. I'm just going to print these variables, right? But if I specifically say, no, I want you to change SEP to equal /n or something like that, right? Then it will realize like, oh, okay, you don't want me to print it. You want me to, just replace it in this function. Okay, so let me just talk about what are these two? What do these two things mean? So remember how I said that when you print out multiple things, they're separated by spaces by default, right? So if I print out, like num1, comma num2, right? Automatically it'll add a space there. That's because there's this separator argument, and by default, that separator argument is a space. If I were to change this separator argument to instead say, hey, let's put commas in between everything, it'll put commas in between everything, right? And similarly, you can also change the end character, right? What gets printed out at the end. And so maybe at the end, I want to print out Jacob was here, right? And so every time I use the print statement with this end, instead of ending with the /n, it'll end with Jacob was here. And so what Jacob used was end equals to space, and that way he can print out everything on the same line. Does that make sense to people? And that's pretty cool. Okay. Actually, let me not undo that, but then we'll put Jacob's name in here. Okay. Okay. So are there any questions about any of this? No? Okay. Manish also put a solution in the chat, so I want to go through that as well. Oh, sorry. There is one more thing I wanted to mention about this solution. We're not even using I, right? And so if a variable is unused, a good technique to use is just use like a underscore or like double underscore or something like that. And the intention is to signify to readers of your code like, hey, this variable doesn't matter. Like I don't actually use it directly anywhere in my code. It's just that I need to iterate through something n times, and this is a way of doing it. So if I execute this, underscore is actually a perfectly valid name for an argument. However, like in general, you shouldn't be doing things with that underscore. Like you shouldn't do print underscore. The idea is just that like you don't confuse it with any other variable. You've just assigned it kind of like a garbage name. Does that make sense? Why you might use the underscore? Yeah, not all languages may support having underscore as a variable name, but Python definitely does. And some languages kind of mandate it, like in the language Golang, it's developed by Google. They basically say, hey, if you're not using this variable, replace it with an underscore, because otherwise we're gonna not even let you execute your code, because otherwise we think there's a bug in there. So yeah, okay, but let's go through a Manish's solution. So num terms equals to this thing. Input 1 terms equals 1 comma 1. If num terms is less than 1, print. Ooh, wow, look at that. That's called error checking. That is beautiful. Invalid number of terms. Else, while n is less than num terms, terms dot append terms n minus 1 plus terms n, and then n plus equals 1. Terms dot remove terms minus 1, print terms. Is this right? Whoa, that's really cool. Okay, so what happened here? Okay, so we started off with the list, kind of just storing all the Fibonacci numbers we had. This is kind of nice. And then every time we iterate through this while loop, again, also could have been a for loop. Doesn't really matter as long as it gets the job done. And so we every time we iterate, we just add the next Fibonacci number to this list. And because of this n-1 and n notation, right? Because he's indexing correctly, he just always gets the last two Fibonacci numbers and uses them to add it together and get the next Fibonacci number. And I think you did this. Why, Manish? Did you end up with too many?
Yeah, I did end up with too many.
Okay, so that makes sense. So one way you could do it is also just to save yourself some extra computation, and then you don't have to delete it like this. You could start with like that. Yeah, so he starts off with two numbers, right? So if he iterates through this,
Since I need that for the summing.
yes, he needs it for the summing. So if he were to iterate through this 5 times, then he would end up with like 6 numbers, right? And then so yeah, anyway, we want to end up with just or sorry, not 5 times. If you iterate through this what is it, 4 times? Because he starts with n equals 1. Yeah. So that's 2 plus 4 would give you 6, right? So maybe yeah, instead he's like, okay, well let me just go through this 4 times, but then remove the last one. That gives me 5. Another way you could do it is just maybe start with n equals to 2, because maybe now n makes sense as, kind of representing the number of terms that are already in this list. And so this, oops, wait, what have I done here? Oh, now I have to adjust this indexing though. Okay. This also works. Nice. Cool. So I don't want to say that you're graded on elegance, because you're not. Yeah, it depends on the competition, but you're generally not graded on elegance. But the more elegant your solution, the more elegantly you write this, the easier it is. So I really like, these solutions. This was like really nice, you found this kind of self-similarity within the problem, right? How it repeats. And similarly, for Jacob, he did this beautiful thing with swapping the numbers like this. This also works. I like it. Okay, nice. That was a lot of time, I know, on one problem, but the rest I think are pretty easy. Okay, write a program that asks the user for a positive integer and calculates the sum of its digits using a loop. Any thoughts on this? Anyone have any solutions? Jacob and Manish helped us out a lot. Anyone want to paste their solution here in the chat? No one has a solution to this one? Did people actually struggle with it? Or okay, important math. I see. Nice. I think at some point I switched between Jacob's and Evan's solution, writing it in the chat. I didn't realize. Okay, let's try this solution. Okay, 148. That should give me 13. It does. Nice. How does this work? Well, the way that Evan has written this is he's basically this represents the index of his number where he's starting off, but he's technically doing it from the back, right? And so he's like, okay, this first digit from the back, second digit from the back, third digit from the back. Indexing can get a little confusing when you do it this way, but this is I mean, this is kind of all you can do. So he's doing n plus equals 1, L plus equals m percent 10, m equals m slash 10. So what is happening? So he's taking 148 and he's like, let's take the 8 and add it to some like variable that's showing the sum, and then divide 148 by 10 so that we're left with 14. And we're doing integer division. So we just are left with 14. And then 4 and then 1. So this works. This is nice. And no worries, Jacob. I didn't like Zoom kind of like I was looking at your solution, then I started looking at it. I didn't even realize what your solution was. So okay. But your solution does work, I think, for that 14. So that's pretty good. Prime. Okay. Now Manish. Manish has I think this what Manish did is he's not even relying on indices. So oops. So this can be nice in the sense that like that hey, once the number is 0, once you're left with basically nothing, because 1/10, if you were to do integer division on this, you'll be left with 0. What he says is, yeah, once I'm left with just 0, then I'm done, right? And so that's a good stopping condition. That might prevent you from making any issues with indices. Because remember, some of these competitions, sometimes like on like tests or interviews or things like that, you don't have a compiler. You can't actually even run your code, right? So, our computer science teachers or professors at Stanford would used to say like, hey, yeah, you guys are writing code out in your test. Yeah, 90% of people's solutions don't even compile. So yeah, the things you can do to, reduce bugs as much as possible, that's what's important. Now, of course, like if you are doing tests that are written down, like and your code, if there's someone were to type it up, doesn't even compile, like they're not going to be mean. They're trying to grade you on understanding. But yeah, the better your code is, that's always helpful. So does it make sense how it's the same thing that Evan did, but he's just using a different kind of while condition. Something else you could do is so that you don't even have to subtract this, right? This works. You could also say number equals to number //10, the way Evan did, because this will give you just the integer division. This will give you basically like how many times does 10 go into this evenly. And something if you want to be even fancier, just assign it to the number itself, you could do // equals 10. Does this notation make sense to everyone? The fewer characters you write, the less chance of making a mistake. That does not mean you try to make, code as like compact as possible to the point that you don't know what's going on, but yeah. Okay, and then I'm trying to, let's see, paste Anirudh's thing. Okay, 2list equals lister number. Oh, this is interesting. Okay. Y is less than length. Sum plus equals int number I plus equals 1 print sum. Okay, so Jacob, I think your solution is kind of like Evan's in the sense that you're keeping track of like how long is this number, right? And that's interesting the way you did it. So both Anirudh and Jacob have basically converted the number to a string. And why did they do this? So if I do this, I'm left with nothing. Let me start off by saying this. So if I do this, if I convert it to a string, which is very easy in Python, even though I will say that this is an operation that takes a lot of time in terms of processing power. But if we're just looking for a solution that gets us something, that's fine. And so this the length of this number, it's easy to determine because we can get the length of a string using the len operator, right? So how large is 148 in terms of characters? All right, it's 3. Length is 3. Nice. And then what Anirudh did is he used that he realized that, hey, like strings are just list. So what I could do is I can convert this to a list right? Like, so at first he converts it to a string, and a string is just a list of characters. So then he converts it to a list. And so now we get something like 1, 4, and 8. Okay, sum equals 0 for I into list. Sum plus equals int I. So then he iterates over this list, and he does so by saying, hey, let's take that 1, and that's a character right now. Let's convert it to an integer using this int function, and then we print the sum. This works. I think you don't even necessarily need to convert it to a list. You may be able to just say, hey, let's iterate through the stringified version of the number. Because again, strings are just lists. So list of characters. So this is kind of cool. Okay, and then Jacob, I think your thing is similar actually. Yeah. So you're also converting this to an int. Nice. And then you're using length to figure out when to stop. Nice. Yeah. The thing about something like this is if you just use the length of if you just iterate through a list, it'll stop at the end of the list naturally. So yeah, if you did something like for I in number, right? Then you could do sum plus equals I. And this, yeah, and that would give you the same solution as anyway. This is nice. Okay. Cool. Okay, so 16, write a program that asks the user to enter a password, validate the password according to certain criteria like minimum length, specific characters using if statements. So this is interesting because, well, this is, I mean, it's up to you, kind of like what you want. This is kind of a free-form question, but we can say things like, okay, if len of password is less than 5, print invalid password, too short, and use more than 5 characters, something like that. Use 5 plus characters. Okay, but now what else can we do? So this might take a bit more exploration of functions in the Python library, but we can do interesting things like we want to check maybe if where is the documentation? I don't care about this stuff. Okay, so alphanumeric. So if you want to check if all the characters are alphabetic, right? This will say, hey, if I call the dot is alpha function on the string, and this returns true, what does this mean? What does it mean if this returns true? This stir dot is alpha. Feel free to unmute. Please unmute. I can't hear you. It means no special characters in the string, right? Yeah. So people only use alphabetical characters, no numerical characters, no like special characters, right? So we could say something like, hey, if password dot is alpha, print must have at least one number, right? Then let's say we say lf password dot is numeric, something like this. We can say print, hey, must have at least one letter, right? And if everything is alphanumeric, we can say print must have at least one special character. Actually, it's not is numeric. I think it's digit, but oh, this is also is numeric. Oh yeah, so is numeric would allow you to have like periods, I think, like 3.5 might work, or 1/1/5. So yeah, numeric is a little more expansive. Yes. And then I don't know, we can also say is ASCII, right? Like if they're all special characters, that could be bad, So, but you get the point, right? Like how we might do something like this. And so now let's see. Oh, wait, one thing I should say at the end, else. Oops. Print satisfied criteria. It's not, it's alphanumeric. I just saw it. What was it? Alnum, sorry. Okay, alnum. I have to spell that correctly. Oh. See? Secure password. Boom. Did anyone have any other conditions or anything similar? Did you use a for loop, or how did you guys do this? Anyone? No one. Okay. No one attempted problem 16. Fine. Okay. We can move on to, okay. Well, thank you, Jacob. Okay. So write a program that prints a triangle pattern using asterisks given the number of rows specified by the user. And so the rows equals int input, enter the number of rows for in rows, blah, 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 print I. Okay. So, ooh, actually, Jacob uses a function. That's very fancy, but let's not use a function yet. I like how you commented your code, Jacob. Makes it easy to follow. Actually, I don't need to run this because it's okay. Interesting. Did I run your code correctly? Is this right, Jacob? Did I indent?
No, that's not it. Well, let me check what I have written. Did you use the function?
I just took it out of the function since I haven't gone over functions exactly yet, right?
Oh, okay. Then, why aren't the leading spaces there?
I don't know. And equals. Oh, I think I indented too much here. That makes sense. Okay. Ah,
No, but the leading spaces still aren't there. It's not a pyramid.
okay. Let me see what Manish did. In the meantime, if you can figure it out, this would be great. But so he of course started out with the same thing, and then we say for I in range rows plus 1. Let's print out I asterisk. Okay, so this is a triangle, yes. I can take if you were going for a pyramid, right? Which would be cool.
Yeah, that's what it asked for, though. Triangle pattern.
I mean, triangle, pyramid, it all works. I mean, no, pyramid works for sure. I'm not saying it doesn't.
Okay.
Yeah. So, but yeah, I agree. This is it's not printing out the leading spaces. Something's a little strange in Colab. Oh, because this should be an I. That makes sense. It's printing out the same number of leading spaces for everyone. Okay. Hey, this is really cool. Okay, so let's just go through both pieces of code. So what's happening here? Well, for every single row, right? We want to figure out what's the number of spaces to print out and then what's the number of asterisks to print out. So if this is row 1, row 2, row 3, row 4, right? Row 1, we want to print out first, let me just explain what happens. So every row we have 2 more asterisks than the one before it, right? And as a result, there's 1 less leading space. And so basically what Jacob did is he's using this I in order to figure out like, hey, how many leading spaces should I have, right? The smaller it is, the more leading spaces he needs. And so if n is 5 in this case, I guess this gave me just 4 rows, right? Why is that? 5, 6, 5 minus 1 is 4. So this gave me 4 leading spaces, as one would expect, right? 3, 4. And then it prints a leading space, and then it prints out basically 1 plus 2 times I, right? That's how many where's the 2i minus 1? Oh, I see. I think I want this, right? Is that right? Oops. That's too much. Oh, because 1 to 2, I see. 1, 3, 5, 7. But is this what you're getting, Jacob? Just 4 rows?
Wait, which one are you looking at? The bottom one or the top one?
Yours, right? This is yours for 1, 2, 3, 4 rows.
No,
top?
for me, I'm getting all 5 rows when I put in 5.
Okay.
Yeah, I redid it without the function. I'll send it.
I see. Okay. Interesting. Oh yeah, that would help if I was
Where is
actually-
n defined?
Yes, thank you. That's it. Let's do that. Okay. Beautiful. Okay, so now this makes sense. Okay, great. So we have 4 leading spaces, and then this says, hey, print out K once. And then for every I increase in I, right, we print out 2 more asterisks each row. And then we print out 1 fewer space. Does that make sense to everyone how Jacob got this beautiful pyramid design? Okay. And then Manish gave us this, which is just printing out 1 asterisk, 2 asterisks, 3 asterisks, 4 asterisks, 5 asterisks. Again, still beautiful triangle. Nice. Okay. Now this is interesting. Write a program that asks the user for a string and checks if it is a palindrome. Read the string forwards and backwards using if statements and loops. So let's see. One thing you could do actually inside of Python, there is a fancy function called reverse. Excuse me. And so if we have some word, we can say reversed word equals to, and then we can say let's reverse the word, but this doesn't return a string and return some sort of like reverse iterator. So let's convert it to a string. And then we can just say, hey, if word equals reversed word, print palindrome, else print not palindrome. Okay, so race car. What? Hold on. What have I done here? Print reversed. Oh, it's still converting this to right around object. I might have to convert this. Why is it not getting converted to string? Can I do this? Okay. Okay. This is
Yeah, I did something similar. I put my code in the chat.
Wait, Manish, what are the 2 colons that you have in the word do?
Yeah, that reverts to it.
yes.
The 2 colons and -1.
Yes.
So it like completely reverts the entire word?
Yeah.
Okay, thank you. Wait, what if it was like -2 afterward instead of -1?
Well, -1 accesses the last index. So I think if you put -2 instead, one of the letters would be missing, I believe. I'm not fully sure.
Okay, got it.
Yeah. So this is a really cool thing. So I need to.
Sorry, just to answer what happens if you put -2, I think what it does is going to skip from backwards. Like it's going to skip every second letter, I think is what's going to happen.
Oh yeah, it's like it skips over every single.
Yeah,
Okay, that makes sense.
the backward.
Yeah. So this -1, this last thing, it's called the stride or the spacing, basically. So if you remember yesterday with our indexing, if we wanted to skip every other letter, we might do like colons too. In this case, Manish wants to iterate through this backwards. So he says R, A, C, E, right? But yes, if you were to do -2, it would go R, and then it would go over the C, and then this other C and this other R, right? -3 would go from R to E to R. Does that make sense? How this negative indexing works? And or sorry, not just the negative indexing, but this negative like stride length. So this is very cool. Yeah, so this works. It allows you to go through the reverse. But technically this does use if statements and loops. So what we can say is for I in range len of the word, right? We can say, okay, actually, instead of starting at 0, we want to start at, so we want to compare the what's at character 0 to what's at -1, right? So we can say if word I equals, sorry, is not equal to what's at the opposite position, which is or so one thing we could do is use positive indexing, or another thing we could do is negative indexing, right? So 0 would match up with -1 if we do it negative indexing, 1 with -2, right? So basically I have to just do -I minus 1, right? So if these aren't these aren't the same, then just say print not a palindrome and then just break, because we don't have to evaluate anything else. If we get through the whole thing and it's fine, then we should have some sort of variable to make sure that, you know, palin is still true. Right. This works similarly. Now it's actually probably evaluating twice as many characters as it needs to, because we only have to go through like half the word, right? So we might say something like this is all we need to do. Yeah. And so this might skip the middle character if it's an odd number of characters, but that's also fine because we don't actually need to evaluate if the middle character is equal to itself. So, okay, nice. Okay, 2 integers are given, print the values of the smallest of them. Should not have left that in, but okay, one is min of a comma b. You could just return this. And then another option is if a is greater than b, print b, otherwise print a. Okay, then in mathematics, the function sine of x is defined as follows. So if something is greater than 0, it's 1. If it's less than 0, then it's -1. Otherwise, it's 0 if the x is 0. So how would you calculate this? Using if, elif, and else. You could just say if x is greater than 0, print 1. Elif x is less than 0, print -1. Else print 0. Cool. Okay, 2 squares of a chessboard are given. If they're painted the same color, then print the word yes, and if they're painted different colors, then print no. The program receives as input 4 numbers from 1 to 8 each, specifying the column number and row number. First for the first cell, then for the second cell. Now, admittedly, this takes a little bit of prior knowledge, right? So what's the prior knowledge? Well, every other square for a chessboard is alternating colors. And so Jacob has this suggestion. So let's try his. So if y equals y2 and x2 minus x1% 2 equals 0, or okay, print. Yes, alt print. Okay, so one thing he's saying is like, okay. By the way, do people want me to draw out a chessboard? Let me do that so you can see it. So let's say, let me just make this simple for myself and make this 4x4, right? So it's usually 8x8, but basically every other square is colored in, let's say, and this is blue, and then every other square is white. Remaining squares are white. Okay. Does this make sense? So what Jacob is saying is, hey, if they're in the same y value, right? So that would be this. So if they're in the same row and the x's are an even number of squares apart, then yeah, they're the same color. Or if they're in the same column and the y's are an even number of rows apart, then yeah, they're the same color. Or if x2 minus x1 equals y2 minus y1, which basically is saying like, hey, if the x's are the same distance away from the y's. Is that what you intended to say, Jacob? So what you're saying is like, hey, if our first square is here and our second square is here, then they're the same color, right? But this doesn't capture all cases, right? Like what if our first square is this one and our second square is this one? They're not in the same row, they're not in the same column, and they're also not the same number of x and y apart, but they're the same color. Right. Okay, so I think you're close. What you wanted to probably say is basically if, let me stop annotating. If this %2 is equal to this %2. Does that make sense? Like if they're separated by an odd number of rows, they should also be separated by an odd number of columns to be the same color. Or if they're separated by an even number of rows, they should also be separated by an even number of columns to be the same color. And then in that case, if you have this as your condition, you don't even need this. These are kind of like more specific versions of this case. And then Evan has come up with a solution as well, which is just look at the value of x1 plus x2 plus y1 plus y2 for %2. If it's 0, output yes, I'll output no. Let's try that. Great. Okay. And I should define these, but let's take a look. So if x1 and x2 plus y1 plus y2 %2. Okay. So why does this work? So the thing is, ultimately what we need is Are people familiar with the concept of parity? Parity. You can kind of assign each cell parity, and you kind of want all the cells, like all the cells that have the same color have the same parity, right? So if we call this like a even cell, then this is an odd cell, right? All odd cells are the same color, all even cells are the same color. So what Evan has done is kind of equivalent to what this last condition Jacob wanted is, right? What he's saying is like, hey, okay, if x1 and x2, if it were odd, that would mean that one of these is even, one of these is odd, which means they're separated by an odd number. And so then for this cell to be the same color, as the first color, for both cells to be the same color, then that means that these also have to be separated by an odd number of cells, which means that one of them has to be even, one of them has to be odd. But then if one is even, one is odd, one is even, one is odd, right? Then two of them are odd, two of them are even. That means they're both, that means the whole sum is even, which means when we do modulo 2, that will give us a remainder of 0. Wait a minute. Let's think about this. So let's say this is 2, 1, right? Or what should we call it? Yeah, 2, 1. And this is 3, 2. So 2, 1, 3, 2, that gives us 2 plus 1 plus 3 plus 2. That's 3 plus 5 is 8, right? 8% 2 is 0, right? But what we should change this condition to is say equals 0, right? Right, Evan? Or would you agree that they're the same color if it equals 0? So does this make sense to everyone? Why this also works? Like also like if x1 and x2 are separated by an even number of squares, right? If they're both odd or if they're both even, right? Then y1 and y2 also have to be separated by an even number of squares. It should both be even or both odd. Yeah, negative 8% 2 is equal to 8% 2 for all integers. Let me think about it. Yes. So nice. Yeah, that's a great point. Yes. Over here, he basically just changed the sign, right? So this is nice. Okay, but the reason why I'm saying it has to say equals 0. Python, when it comes to evaluating if-else things, right, or when it comes to evaluating conditions or booleans, it uses what are called falsy values, right? So JavaScript also does this. Jacob, you're familiar with JavaScript. Anyone else know what I'm talking about though with falsy values? Anirudh, yes. Minu, you should know, right? Okay. Evan, Manish, no. Okay, that's fine. So basically, if a number is 0, so if I say if it's 0, print this, it's not going to print anything. If I say if 1, print this, it'll print something. If I say if 2, print this, it'll print something. If I say if empty list, print this, it's not going to print anything. If I populate the list, it's going to print something, right? So what's happening here? So for falsy values, how do I put this exactly? So for values that are kind of like the empty type or empty version of their type of their data type, those are considered false, right? So for int or 0 is considered false. For float, 0.0 is considered false. For a string, empty string is considered false. For a list, an empty list is considered false. For a set or a dictionary, right? Empty set is false. Empty dict is false, right? All of these things are considered false. So if I say if something modulo 2, right? If I say if x% 2, print this is even, this is not doing what I intended to do, because if x% 2 returns 0, right, then it's even. But if this is 0, then this is false, right? So I have to say x% 2 equals 0, then say this is even. Nice. Okay, so that's just something to keep in mind. Yeah. So and of course for bools, false is false, right? Does it make sense though how we have other values that are considered false? And so this is also the quick hack. Like if you want to just check if like maybe you return all valid values inside of a list, something like that. Then you might check the list and say like if list, then do something with all the valid values, right? Now, if there are no valid values, that if statement won't even execute because that list will be empty. So it's a quick hack. It's nice to have falsy values and nice to have this, like, you don't have to check the length each time. It will just say like, okay, if this is an empty thing, do nothing. But if you don't know about this, then that might be an annoying optimization because it's not doing what you want. Okay. So let's go on. A natural number is given. How do you determine if it's a leap year? I think this is pretty easy. So if y percent 4, right? So if this returns 0, then we care about it. But we also need to make sure if it's a multiple of 100, then that must also be a multiple of 400. And y equals, so if it's not a multiple of 100, right? Then this should evaluate to true. So let's see. So if y percent 4 and so if it's a multiple of 4, right? But it's not a multiple of 100, we're fine, right? But let's say it is a multiple of 4, but it is also a multiple of 100. Right now, this won't evaluate to true. So we have to say, but if it is a multiple of 400, then we're fine. Does this make sense? How I'm doing all of this within one if condition. Does that make sense? How to write such a kind of complicated condition? I'm thinking about it. So I need, for sure, it needs to be a multiple of 4, right? But it either needs to not be a multiple of 100, or if it is a multiple of 100 and this is false, then it has to be a multiple of 400. Okay. Hey, yeah. Have any of you, none of you lived through the year 2000, right? That was the last leap year. That was a multiple of 400. You guys are going to have to wait another 376 years. Okay. 3 integers are given. Print the value of the smallest of them. Okay. So one way I could do this is just say print min of A, B, C. That's obviously not going to use if statements though. So let's say, hey, if A is less than B, then if A is also less than C, print A, else print C. Oops. Ultimately, you can only compare 2 numbers at a time. So otherwise, if this is false, then we know B is smaller than A. So then we should do the same thing except with B. Makes sense? Okay. A chess rook moves horizontally or vertically. Given 2 different squares of a chessboard, determine whether the rook can get from the first square to the second in 1 move. I think maybe, Jacob, some things you were doing for that coloring problem might be relevant here. So ultimately, what we need to see is, hey, is it in the same column or is it in the same row? And this is a very easy one. So either we say if x1 equals x2 or y1 equals y2, then print yes. Does that make sense? Because a rook can only move horizontally or vertically, it needs to be in the same row or same column, the 2 points. Now, if we want to be tricky about it, we could maybe say that, hey, like you can't get from where you are now to where you are now within 1 move, right? Like if you're going to make 1 move, you would have to move off that square if you're moving that rook. Does that make sense? So maybe if we want to add a condition, another condition, we could say something like, and not both of these things, right? Does that make sense? Like we want to make sure maybe that both squares that we're given are not the exact same. That's kind of a narrow edge case. Never really specified it. This is just, I don't know. adding funness to the problem. How did I do this again? Oh my God. Okay, so 3 integers are given. Determine how many of them match. The program should output one of the numbers 3 if all the numbers are the same, 2 if 2 are the same, or 0 if all the numbers are different. Okay, so if A equals B equals C, right? We can say print 3, right? Otherwise, LF, if only 2 of them are equivalent, right? And we know that it'll only get to this LF condition if the first one isn't true, right? So we only have to check that 2 of them are true, and that will also tell us that the third one, sorry, we only have to check if 2 of them are the same, and that will tell us that the third one is not the same, right? And then finally, if none of this is like, true, right? There are no numbers that match with anyone else, right? Every, of course, number matches with itself, but yeah. This works. Okay, the chess king Morse horizontal. Blah, 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 blah. Okay, so chess kings, as you guys may know, only can move 1 square at a time, but they can move diagonally, right? So how do we figure out if this king can move between x1, y1 to x2, y2, right? So 2 options. One is basically, and one thing we'll enlist the help of is the absolute value, because we don't know if they're moving up or down or left or right, right? So we can just say, hey, what's the absolute value of the difference between x2 and x1? And the absolute value, let's just say, let's call this x diff. And then let's call this y diff. Okay. So if x diff equals to y diff, well, sorry, if x diff plus y diff is 1, right? Or let me think about this. So let's just say if x diff is less than 1, less than or equal to 1, and y diff is less than or equal to 1, then we can say yeah, print yes, otherwise print no. And so why does this work? It's because, I mean, you can be different in the x or y by 1, and you can move diagonally, so you can also be different in both of them by 1. Does this make sense? And so I think, let's see, Evan, interesting. That's an interesting thing that you did. I would actually, I would say for your case that works. You can also say less than or equal to 2, which ultimately ends up being the same since x1, x2, y1, and y2 are all integers. But what Evan did is basically he, instead of taking the absolute value, he squared it, right? And so that will also give you a positive number. And then he said, okay, the sum of this should be less than 4, which basically means that we don't ever move more than 2 units in any direction. So that works. Nice. The chess queen moves diagonally, horizontally, or vertically. Okay, basically either the x and y are this, x or y have to be the same, right? So it's very similar to the rook, but also, and you know what, let's just get rid of this condition because this is a little too extra. We can maybe check at the beginning and say like, okay, if these are the same, like this is invalid input or something like that. But yeah, so if they're the same x or same y's, it works, right? But also we need to check if diagonally it works. So diagonally, that means that the difference in x has to be the same as the difference in y. We don't know this, like it could be any slope, right? Like it could be that the queen goes from here to here, right? So +1 in x, +1 in y, or it could be +1 in x, -1 in y. So ultimately what we want to just check is, hey, is the difference in both of these equivalent? And if that's the case, then yes, otherwise no. Right? Make sense? Okay. Now 28, a chess knight moves in the letter G, 2 squares vertically in any direction and 1 square horizontally or vice versa. Given 2 different squares of a chessboard, determine whether the knight can get from the first square to the second in 1 move. So that means that either x1 and x2 should have 1 difference, y1 and y1 and y2 should have 2 difference, or the other way around. So again, I'm just going to copy and paste this from above and say, hey, so if x diff equals 2 and y diff equals 1, or so that is nice. That's a nice solution, Evan. Let me get to that. And what Evan said he did is like he's just said, hey, if I squared this x diff and y diff, then the sum of that should be 5. Another thing you could also do is just say, hey, x diff plus y diff equal to 3, right? Because that means one of them has to be 1, one of them has to be 2. So these are nice, clever solutions. Yeah, kind of mathy, but okay. Okay, there's just 2 more. Okay, the chocolate has the shape of a rectangle divided into n by m slices. The chocolate can be broken once in a straight line into 2 parts. Determine whether it's possible to break off a piece of chocolate consisting of exactly k pieces in this way. The program receives 3 numbers as input, n, m, and k, and must output yes or no. Okay, so any ideas for this? Oh, that's a good point. Yes, you can't have this. You're right. You're right. You're right. One of them would be 3 and the other would be 0. Yeah, so you have to make sure that we also say n, not x diff, and not y diff, right? So that we can't have both zeros, both 3s. Thank you. Yes. Okay. Any thoughts on 29 or 30? So let's see. What did Evan put in the chat? Oh, sorry, Jacob put it in the chat. Okay, thank you. Thank you. Nice. So if k% n equals 0, nice. This is a really, really good solution. So as you can see, this is a bit math heavy, these kinds of problems, right? You have to think about this like logically, critical thinking, but also like it's a little bit of, math. But what Jacob did is basically he said like, hey, ultimately what we need to know is like if you think about, let's draw a chocolate bar on the screen, which suspiciously looks a lot like my chessboard, right? We could break it off here, right? We could break it off here. We could break it off at any of these points. We could break it off at any of these points, right? But the question is, can we break off a piece of chocolate consisting of exactly k pieces in this way? And ultimately that means that k, he's saying, needs to be a multiple of m or n, right? And then if it is a multiple of n, then k over n should be less than m, right? If it's more than that, that means k is more than n times n, which doesn't make sense. Does that make sense to people? So that's a very, very, very well done solution, Jacob. Nice. Okay. And then the last one, I think there's a bit of a typo in there. So I think that's why it didn't make sense. Ignore that day per day. So it's rising A meters per day and it goes B meters down during the night. This is a very classical like math problem. Like, yeah, I don't know, you'll see this, I think, in a lot of kind of quizzes. And the trick here is basically if the let's say the wall is like 10 meters tall, right? And the snail rises 3 meters per day and goes down 2 meters per day, right? You might think, oh, okay, so it made only like 1 meter difference in any 24-hour period, so it takes 10 days to get up to the top. That's not quite true because after 7 days, it'll be 7 meters up, then it'll climb 3 meters. That's 10 meters, and it'll get to the top of the wall. However, of course, yes, does it fall back down during the night? Yes, it goes back down 2 meters, but that's beside the point. We're just saying like when does it first get to the top of the wall or top of the pole? So yeah, so okay, Evan might have had that same issue. Ooh, okay. Wow, that's an interesting solution. Okay. So it's very similar to okay, nice. So what is the difference that you rise in height every single day? It's A minus B, right? And so what Anirudh has said is, hey, I know that like I'm going to progress A minus B like in any 24-hour period, but if I'm B meters away from the top of the pole, right? Then that means that day, right, I will get to the top. So let's try this with actual numbers and then see if it makes sense. And then you should always do this with any problem. So let's try it with the numbers, like 10 meters for the height, and then 3 for A, and then 2 for B. So we said that the answer for this was 8, right? Because it takes 7 days to climb 7 meters, and then on the 8th day you climb 3 meters, and you've reached the height of 10 meters, right? So in the case of this, 3 minus 2 is 1, 10 minus 2 gives us 8, right? So 8 over 1 is 8. So it works for these cases. But let's try maybe something like 4 and 2, right? So in this case, we would have it would take 4 days. Right? So it takes 3 days to climb 6 meters. And then on the 4th day, you climb up to 10 meters. Let's plugging in these numbers here. So if we have 10 meters for the height and B is 2, that's 8. And then we divide by 2. This gives us 4. It also works for this. But Evan, you think it's H minus A over A minus B. Interesting. Any thoughts from people? Like which one do you think is right? Can you come up with a counterexample? Anyone?
I feel like
Plus one.
Anirudh's right? Wait, what were you asking again?
Yeah. Which one of these is right? Is it this one or is it this one? I think Evan has this solution. Or is it the same thing? Oh,
I mean, it depends on the value of A.
well, yeah. So we need a solution that works for every single value of H, A, or B.
Yeah, like okay, if I think I could be wrong, but I think if A is 3 and B is 1, the way that the one on line 7 works, it would work out to be 5.
Mhm.
And then the same thing happens on line 9, right? No, on line 9 that would work out to be 4.5. So you would need the ceiling function to wrap around the 1 as well.
Mm-hmm.
But still, I think if A is like 5, I don't think it works.
Yeah. So I think we've actually converged to the same solution for both of these. And Evan's pointing out why in the chat, because one is just A minus B over A minus B, right? And so, I mean, this is wrapped inside the ceiling operator, but let's just put it in since it's an integer. We can add A minus B over A minus B inside of here. And so then this just gives us H minus B over A minus B. So these are actually the same thing. And the idea is, and what Anirudh's like solution maybe shows us directly is like, hey, if I was within B meters, if I was within B meters of the ceiling, right? I'm sorry, or of the top of this pole, right? That means that because I climb A meters every day and A is definitely greater than B, right? That means I definitely reach the top of the pole during the day, even if I've like fallen down at the end of 24 hours. Does that make sense? So yes, everyone's right. This is exciting. Okay. There's always multiple ways to do things. Yeah, nice. Cool. Do you guys have any questions on all of this? I know like it's 8:31 and we're long overdue for a break. Any questions, or we can take a break? Cool. Let's take a break. Be back here by let's say 8:37 Pacific. Okay. See you. Hey everyone, welcome back. Just wait a few minutes for Jacob and Mino. Mino is here. She's just eating. Jacob is here. Okay, great. Everyone's here. Hey, I have to really say I was so impressed, honestly, by a lot of the answers you guys have been giving over the past 1.5 hours. It's very impressive. And I have to say, like, a lot of these are also they're mathematical tricks, maybe it feels, but it's not all problems are just about like, oh, hey, can I like find a quick formula? Sometimes it's more about like finding an algorithm that's clever for something. But that's also, I mean, can be, math heavy. But like it's also kind of drill and kill in the sense that like if you practice a specific algorithm enough times, you'll see like, oh, I know where to apply this. Like it gets used here. So anyway, this is maybe a little bit because we're trying to keep the problem simple and not use fancy algorithms. As a result, there's a lot more mathematical tricks and twists to some of these. That won't always be the case. But yeah, people were mentioning like, hey, this is frustrating somewhat, with the fact that you have like, questions where they're using chessboards as an example, right? And maybe you know what a chessboard is, but you don't really play the game of chess. So like, how do you approach such a problem? So my solution is always to draw a diagram, draw a picture. This is always, I think, helpful for, math or physics or whatever. Anytime you don't exactly know what's going on, you have to find a way to picture it. And then once you picture it, try some base cases, try some simple examples, and kind of give yourself a handle on the situation. And that way you can then maybe generalize it and figure out like, is there like a way I can write this with code? Because sometimes, like if someone were to ask you like, hey, are these two colors on the colors of the two squares on the chessboard the same? That's pretty easy to figure out, especially if you have a chessboard right in front of you and you're just being asked as a human being. But if you're trying to write code for this and make sure that code is always correct, that might be tricky. So yeah, basically just try different cases. And oftentimes what you'll do in like, in real life when you're writing code, you'll write test cases and you'll make sure that there's like some kind of test bench or test suite that gets executed every time you make updates and make sure that the test still have valid answers. So yeah, test cases, diagrams. Do any of you have other strategies that you may have applied for this problem, or maybe that you applied to like, math competitions, for example, or things like that, or tricky problem solving?
ChatGPT. Great
ChatGPT.
strategy. Great
Yeah.
strategy. I recommend it.
ChatGPT is a
And Google and Monkey Code. Put all three of those together. Mwah, beautiful.
wait. What are the other ones? Monkey Code?
Google Monkey Code.
Not familiar with Monkey Code.
It's like a thing that uses AI to write code. It's like specifically a GPT that writes code for you. Because ChatGPT in of itself is kind of bad at it.
I see. Okay. Um, any non-tech strategies?
At least like breaking it down into smaller steps.
Yes. A good idea. Yes. And that's also very helpful for writing code just in general. Like, yeah, exactly. That way, like how to, for example, find a palindrome. Well, what is each step of finding a palindrome? Maybe comparing the letters that are on, opposite sides of the word, things like that. Okay, great. So, okay, well, let me get started with functions. I know that some of you know functions, but I want to, and some of you use functions in the homework clearly, but I want to go over it formally. So, okay, what is a function, first of all? If you are going to write a piece of code that gets called like multiple times, usually the rule is like, if you call some piece of code 3 times, right, it should be its own function. A function is just something you can call separately, the same way we call like the ceiling function or square root function. You can pass in some inputs, you can pass in no inputs, you can pass in some inputs some of the time and maybe other inputs other times. And then it will execute in theory, like if you're writing good code, every function should have a well-defined, clear purpose. People will say that function should be like, 50 lines or smaller. It's not a hard and fast rule, but that's a good rule of thumb. And it should have no side effects, right? There should not be any unexpected behavior. There should be some clear defined, like, I put in this input, I expect to get this output. I expect this behavior to take place in between. And sometimes it might throw exceptions, of course, if you can't handle it, if there's all these weird edge cases, but you need to check for that. So if you write like a divide function that takes in two arguments, A and B, and divides them, you need to make sure that B is not 0. Otherwise, you'll be dividing by 0, and then that will cause an error. So functions, very helpful because you want to be dry with your code. Dry stands for don't repeat yourself. So yes, okay. If I were calling the greet function multiple times in my code, for example, this would be helpful. So what does this greet function do? Well, it doesn't take any arguments in, first of all. So if I were to pass in an argument, it might throw an error. It would throw an error because it doesn't expect to see anything there. But if I call this function, it's going to print hello, comma, welcome. When Collapse decides to start, it'll print hello, comma, welcome. Beautiful. Okay, exactly as I timed. Okay, and then you can have functions with positional arguments, right? So these arguments are basically a comma b. It's just returning a plus b and add numbers, right? And so how do we know which one is a, which one is b? Well, or how does really Python, I should say, know which one is a, which one is b? Well, based off the position of the numbers, right? Since a is specified here first and b specified here second, the first number I provide is going to be interpreted as a, the second number is b. So if I print this result, gives us 8. Of course, addition is commutative. This doesn't really make a difference. But if I were to make a separate function, function called divide numbers, and a over b is what I return, then yeah, we should expect to see 3 over 5, which is 0.6, not 5/3. Okay. Now you can also put in arguments using keyword names. So length and width. These are the names of the arguments. And so I can say, hey, if I want to calculate the area of a rectangle, I'll pass in the length and width. Length equals 4, width equals 6. So if I print the area, this will give me 24. Now, this happened to be the exact same, order in which my arguments were specified here. However, I could run this code while changing the order of the arguments. Now, I wouldn't do this kind of thing too often because it can get tricky. But in this case, multiplication also commutative. So if I say width equals 6, length equals 4, this will give me the same answer, 24. But now width is 6. And width is read in first. Does that make sense? How this works? Like how I can call it by its name rather than just using the position and implicitly relying on it. Now, you can also have default arguments inside of code, inside of Python. Not all programming libraries, programming languages support this. But it can be nice when you have it. Just make sure not to make mistakes because of it. So if I call the greet function, the name equals anonymous will be passed in by default. But if I want to override that, if I want to specify another name, I can specify it by saying like John or whatever. Or I can, even say my name, right? But I can call it using the name argument and say, hello, come and be good. So greet by itself, no arguments. It'll use the default argument of anonymous. John will replace anonymous. Bugit will replace anonymous. Okay. Functions with variable length arguments, multiply numbers, asterisks, args. So let's say you wanted to multiply, tons of numbers. You don't know necessarily, you don't want to limit yourself to just having 2 or 3 or 4, right? The same way the print function doesn't just say like, hey, you can just only pass in one thing to me. You could pass in 5 different things and print all of them out. So how does that work? It uses variable length arguments. So variable length arguments, this basically just says like, hey, I'm going to pass in like a list of arguments to you. I want you to, use all of them basically. So this asterisk args, that's the notation for it. That's how you know that there's a variable amount. And as you can see, multiply numbers. We start with the product. We multiply every single number inside of arguments, and then we return the final product. So as you can see, args is being treated as a list here. Does that make sense? So I pass in every argument individually, but the way this function receives it is kind of like as a wrapped list of all these things. So it's like it's seeing the input something like this, 2, 3, 4, and so then I can do some operation on all of the numbers. Does that make sense how this works? Any questions on these variable length arguments? Everyone's good. Okay, cool. And then I will say that we're probably not going to be using this too much in class. But variadic arguments is also another name for it. It's helpful to know. Okay, functions return values. So we haven't been focusing too much on the return value right now, but you can return values, right? And then you can catch kind of the value that's being returned from this function and save it and in a variable. So if the numbers list is 47925, right, I pass that into calculate average. So I can sum up all of those numbers. So this function sum will sum things up automatically for you. It gives you the total divided by the length, gives you the average. It's interesting to me that, like, Python has a sum function, but not an average function built in. But okay, it returns the average. And then we can save that average inside the variable average value and print it out. And that's 5.4. Okay, does that make sense to people? Okay. Now, let's get to recursion. So recursion is a very, very cool topic. We have not touched it before, but we kind of like beat around the bush, and I actually tried to like make you skip questions or like suggest you do it through different ways if recursion was maybe the best option I could think of to do it. So how does recursion work? So there is nothing stopping you from calling a function within itself, right? So this factorial function can call itself. Now, what's the risk of calling yourself? You might go into an infinite loop if you're always calling yourself, right? Forever and ever and ever, right? So you don't want to call yourself forever and ever and ever. You need to have some sort of stopping point, some stopping condition, some base condition, right? And then maybe every other time you can go call yourself. So that's called recursion, right? So there's the base case and the recursive case. So let me see if I can format this again. Okay, so what do we know about n factorial? How do you calculate n factorial? It's basically the same way as you calculate n minus 1 factorial. The only difference is you multiply n minus 1 factorial by n. How do you calculate n minus 1 factorial? Well, n minus 1 factorial is the same way you calculate n minus 2 factorial, but then you multiply that by an n minus 1. Okay. Anytime you see a problem that's self-similar, like there's some kind of like basic subproblem within itself that mirrors the original problem, that's recursion. It's usually recursion. Maybe it's a for loop, maybe it's a function, but usually there's some self-similarity. You want to harness that self-similarity and use that to guide you towards writing like some code for the problem. Recursion, oftentimes, or every time you use recursion, you'll have self-similarity. So in this case, what's the self-similarity? Every time you want to calculate the factorial of a given number, you take the number smaller than it, calculate the factorial of that number, and then just multiply the current number with it. Does that make sense? So what is the factorial of n? That's simply the n times the factorial of n minus 1. Problem solved, right? No, not solved, because we've never defined yet how we stop this, right? So if I just do this, this is not enough. I have to, this is your recursive case. This is good. But what we want to do is make sure we have a base case defined. And so in this case, the base case is n equals 0. So 0 factorial is just defined as 1, right? We can just stop right there. So anytime we have a number that's greater than n and we pass it into this factorial function, it'll be fine. It'll stop eventually because it'll stop at 0. So then what happens? How is this? What is actually happening within the computer, right? So factorial of like, let's say 5, right? That we call this factorial function. It returns 5 times factorial of 4, right? And then factorial of 4, we stop and go off to calculate that. And that's actually just 4 times factorial of 3, right? And then this is just 3 times factorial of 2. And notice, like, you have what's called a stack inside of your computer. I don't know if you've ever noticed when you, for example, have like an error. Python will show you a stack trace. Oftentimes other programs, you know, on your computer will show you a stack trace, right? The stack is kind of where your collection of variables and functions and stuff that you're collecting, the code that you're executing, that's all saved on the stack, right? And so you're building up this stack, and keep in mind, if you're if you're going through too many layers of recursion, right, then it will be a very large stack. And at some point, you might have so much that your stack blows its top. Your stack overflows, right? Anyone heard of Stack Overflow, by the way? It's a great website. If you have any questions about coding, you can put it on Stack Overflow or search them up. Someone's probably already asked them. So Stack Overflow, that's where it gets its name from. So anyway, we don't want to cause a stack overflow. We just want to use a small enough case for factorial that it works. So let's okay. 2 times factorial of 1. And this is equal to 1 times 1. And now we can go back and say, okay, well, this equals to 2 times 1. And then we can go back and say, well, okay, actually, this equals to 3 times 2. And this equals to 4 times 3. And this equals, wait, that's not 4 times 6. And this equals to 5 times 24. And this equals to 120. So this is how the factorial thing gets solved within your computer. Now, I will say recursion can have its downsides. Again, you might blow up your stack, right, by having way too many layers of recursion. It could get slower, right? It might be more optimal to just start with 1 and then go to 2, 6, 24, 120. That's kind of how we did it yesterday, right? The same way that I think like shoot, I forget who was it, maybe Manish for his Fibonacci sequence when he was creating, he started with the list and he started like, okay, 1, 1. And I mean, everyone kind of did some variant of this, but like I like the way Manish did this in a list. So he just kind of listed everything out. So now if you want to optimize your code, and sometimes a compiler will even do it for you, Python will not, because Python is not a compile language, but a compiler will maybe do what's called tail recursion. So it kind of just inverts the recursion. It just starts at the end and it just works its way up to the beginning. So that way you don't have to save too much on the stack. That's way too advanced. That's beyond the scope of this class. The point is just to say recursion, very useful tool. It's not necessarily the only way to solve problems, but sometimes it is the easiest way to solve a problem. Okay, so now Fibonacci, the Fibonacci sequence, can we solve it using recursion? So if you guys can go back to your classwork and where you had the recursion problem, or where you had the Fibonacci problem, if below that you can figure out a way to write this using recursion. I'll give you guys like, let's say till 9 a.m. and let me know, or yeah, 9 a.m. Pacific, and then see if you can come up with a solution for it. Everyone understand what I've asked them to do? Right, we're writing the Fibonacci sequence problem, but using recursion. Are people lost or are they already done? I don't know. I see some lost spaces. No, okay, people are working. Okay, cool. Okay. It's almost 9. If you guys want to get back together. No. Okay. So for the Fibonacci sequence, and some of you may have seen kind of the answer because I was really showing it earlier. Okay, yeah, Minu has it. So what's the base case for the Fibonacci sequence? The base case is the 0th or first term, which are both 1, right? So if n is less than or equal to 1, we return n. Now, what's the... And it might sometimes be more helpful to start out with the recursive case. My fear is always that, like, hey, I need to define a base case, otherwise I'm going to be too excited. I'll run my code and then it'll run forever. But the recursive case is, I think, pretty simple. It's just adding the previous 2 terms together of the Fibonacci sequence. How do you get those 2 previous terms? Well, you just call the Fibonacci function again. So something like this, right? For everything else. I don't even need an else, right? Because if n is less than or equal to 1, it'll return n, and then it'll just leave the function. Only if it makes it back past this do we execute this, and we go to a recursive case. So, oh, and that's basically what, yes, Minu has written. So does this make sense how this works? And so if I put in Fibonacci 5, I get 1, well, okay. Maybe I need to write this out for myself first. And sorry, I should not return n, actually. I should return 1, because let's say the 0th number of the Fibonacci sequence is 1 and the first number is 1, right? Let's do 1, 1, maybe. Well, I don't know. Let me think about this. So 0, 1, 1, 2, 3, 5, 8. Okay. I guess it's fine either way. Yeah, you know what? Let's return 9. That's a little elegant, I think. A little more elegant. Okay. And that way, the first number, the Fibonacci sequence, going by 0 indexing, and the second number are both 1. And then the 5th number is 5. Okay, great. I like it. Okay. So this does seem to work. Fibonacci 5. Let's just try Fibonacci 6. And that gives us 8. Great. So this is working. Is this efficient code? Is this as efficient as, for example, your solutions that you wrote? I would say no. Why would I say no? Anyone have any thoughts or guesses for why I might say this is not efficient? Or the most efficient, at least, implementation?
Is this has to go through the function a bunch of times while the initial solutions were just like adding on like up and up. It wasn't going back at all.
Yes. So what's happening here under the hood? So if I do Fibonacci of 5, it's gonna say, hey, okay, what's the Fibonacci of 4? Plus, you know what? I should just call this F. F of 4 plus F of 3. And then for each one of these, it's going to say, hey, what's F of 3 plus F of 2? And then for F of 3, it's going to say, hey, what's F of 2 plus F of 1? And then for here, it's going to say F of 2 plus F of 1. And then for F of 2, it's going to say F of 1 plus F of 0 plus F of 1 plus F of 0 here as well, plus F of 1. I mean, yeah, we're calling this function, these functions unnecessarily a bunch of times, and we're repeating ourselves. We're repeating our work. Look at that. We keep calling F of 3, right? We call it here and we call it here separately. We call F of 2 here and here and here, right? Yeah, so exactly what Jacob is saying, like, you know, you just do it once, you start from the beginning, you go on. Now, this is just going on a loop, but hey, this is also kind of convenient and easy, and you don't have to think about it. I mean, it was just a 3-line solution, right? So, yes, not efficient. Combined with the smart compiler for a language like C++, it can be made efficient, but it does have its uses. Where, like, you know, it would be difficult to do it in a way other than with recursion. Okay, so let's move on to this problem, power calculation, right? The power function calculates the value of a base raised to an exponent by recursively multiplying the base by itself for the specified number of times. So what is the recursive case here? So first of all, what number should I pass into the power function? What should be the arguments?
The base and the exponent.
Base and the exponent. Great. And then what is my recursive case? Let's start with that. That might be easy to define. Let's say the exponent, by the way, is always like a positive integer.
So the recursive case is power of exponent plus 1 is base times power. So exponent is base times power of base and.
Sorry, your mic is acting up again. Is it possible for you to type this? I think this is what you were saying. I heard the first part. But does this make sense to people why this is the recursive case? What we're basically saying is, hey, like, if let's say I asked you what's 4 to the 5th power, well, you say, okay, well, 4 to the 5th power, it's just 4 to the 4th power times 4, right? I should have used drastically different numbers for that. Okay, so what's 2 to the 8th power? It's just 2 to the 2nd power. Sorry, 2 to the 7th power times 2, right? So I just decrease the exponent each time and I add the base here. And is that right, Evan? Is this what you were saying? Oh no, Evan is frozen for me. But type in the chat if you have anything else. Okay, so this is a recursive case. Great. When are we going to stop? What is our base case here? What should our base case be?
If the exponent is less than or equal to 1?
Less than or equal to 1. We want to have the simplest base case as possible. So what would you say? What is the base case?
If the exponent is equal to 1.
Okay, if the exponent is equal to 1. So let's say if exp equals to 1. And what are you saying?
Return base.
Return base. Out of curiosity, what would you have done if exponent is less than or equal to 1 was our base case?
I would have still done return base, I think.
So what would, if exponent was 0, right? If we have like 5 to the 0th power, right? What is that?
1, okay.
Yes. No, I did say both of these are positive integers. So technically these can go down. Let's say this actually. You know what? Base is a positive integer. base is great, positive integer greater than or equal to 2, and then or this is greater than or equal to 1, and then exponent is non-negative. So that means it's greater than or equal to 0. So let's say exponent can be 0, and this works, right, for sure, right? But if we say exponent equals 0, then we can return 1 and return also the same number for everything. It's probably just a matter of reference, and if you know whether or not you're going to get an exponent of 0 as a possible argument. If my base case kind of helps me terminate this whole recursion process sooner, that's always nice. It's not necessary though. We can also do this. So okay, let's just keep this as our base case. And then our recursive case is this. So if we return like that, we have this. Okay, great. And then let's try running this. Power. Anyone know what 2 to the 10th power is? You guys should have this off the top of your head as computer scientists, by the way. 1024. Thank you. It's always very, very, very nice to know powers of 2. And we know what we were able to calculate this as well. This works pretty well. Nice. Now again, is this the only way to do it? No, we could have like multiplied some number in place and used a for loop or something like that. But this is just an example of how recursion can work. Okay. Let's try one more thing. Okay, this is where it might start to get complicated. Let's try the palindrome question we had, right? Well, let's just pass in a string like S, and we want to figure out if something is a palindrome, right? So what is the recursive case for this? If some string is a palindrome, what is the self-similarity we can figure out in this problem? Anyone have any ideas or any questions, any thoughts? Any thoughts? No thoughts. No thoughts at all. It doesn't even have to be about this problem. Is it a nice day outside?
I think you could do like earlier we did like finding like the reverse palindrome and like checking if it's like the same thing as the normal word. So I think you can do that again for like the if statement. Like if the word is equal to the reverse of the same like word, then you can return like true.
Well, yes, that works, but that doesn't necessarily transform it into a recursive problem, right? It's not something where we can apply recursion to. So the idea of recursion is like, hey, can we take this problem and break it down into a sub-problem plus maybe a little more work? And can we keep the kind of the overall problem the same? So I think Evan has basically boiled it down for us. So he's like almost 100% correct. So let's say S is equal to race car, right? How do we know race car is a palindrome? What's a smaller version of this problem that we can solve to figure out if this is a palindrome? Like let's boil it down into like one step we can do on this iteration plus another sub problem. So what can we do to figure out if race car is a palindrome? Even simpler, like let's not look at all the letters, Anirudh. What would you do? Let's just look at one letter at a time. Where should we start?
Probably check if the first character matches the last one, like what Evan's saying.
Yes. Okay, good. So if we say, hey, is the first character match the last character, right? If that's true, then to determine if it's a palindrome, what else do we have to check? So let's say the first and last character are the same, they match. Great. We can't immediately say that's a palindrome, right? So how do we tell if it's a palindrome?
If like the characters like if A matches to A, and like basically if the letters on opposite sides match to each other, except for this middle letter, because you can't match something to itself because
Yeah,
there's only one copy.
Yes. So we're working our way from the outside in, right? And so we can just, at each step of this recursion, let's just check if the outer letters match. But once we've checked if they've matched, we can just chuck them, right? Now, what do we care about? We got rid of the R's. We're left with ace ka, right? What do we check?
Check the A's on
Check
both
the
ends.
A's on both ends, right? So now we've developed this into a self-similar problem. Beautiful. So how do we write this out in code? Okay, so what's the recursive case? Well, first we check, is the first letter equal to the last character? Sorry, is the first character equal to the last character? Let me say that way. So S0 equals to S-1, right? If this is true, and if the rest of it's also palindrome, right? So that would be 1 to -1, right? Then it's a palindrome. So return basically this. Does that make sense? Everyone get this? Make sense to everyone? Okay. Now, the base case, great, and Evan has figured it out. So the base case can be two things. So let's say this is an odd number of characters, then we're left with one character in the middle. If this is an even number of characters, do we want to say the base case is if there's 2 characters in the middle or 0 characters in the middle? To me, simplicity is always better. And if we say there's 2 characters in the middle for the base case, right? Well, technically this recursive case could figure that out, right? What we should probably put for the base case is if there's no characters left in the middle. So if the length of S is 0 or 1, then we know it's automatically a palindrome, because an empty string is a palindrome and a 1 character string by itself is a palindrome. Right? So does this make sense how this piece of code works? And how we can then call race car here? I should put it as a string. And cool, it's a palindrome. Now, if I put race cars, it's false. Make sense to people? So this is, I think, a really nice example. And like what we've done is basically we called it on race car. And so then that's just separating the RR, making sure that's a palindrome, and then calling it on ace ka. And then ace ka, AA, and sec, right? And then sec. And then E returns true. Right? Does that make sense? So we're comparing these two letters, these pair of letters at each iteration, and then calling palindrome on the rest of it. So figuring out how to formulate a problem as recursion can be tricky. But once you find this self-similarity, it's helpful. And then what's, I think, nice about this compared to the Fibonacci problem is that whatever step we had to do, whatever work we had to do, we're kind of taking care of it first. And then only if that's true, then we go on to the next one, right? And then, I mean, like, there's still a bit of a stack that's created, but it's less wasteful. There's less repetitive work being done. And where we're just kind of trimming the string down as we go along, which is nice. I mean, this is not making a copy of the string. It's just kind of showing a window of the string to the next call of the palindrome function. So it's not like creating too many duplicates of variables also in memory. So that's nice. Okay. Any questions about this? Okay. One thing I want to mention here is, does everyone know what happens when you return multiple like if statement conditions in a row? Like if I say if A and B and C and D. What's actually happening under the hood? So let's say A is false, right? Is there any chance that the overall statement can then be true?
No.
No. Why not?
The way that the and works is if anything is false, then it's automatically false. It needs everything to be true. Um, Unlike or where you could have false as long as there's one true.
Exactly. So there's two optimizations that most programming languages have. So if you have an and statement that has multiple things in a row, right? If one of them is false, it'll automatically terminate early, right? If you have an or statement where multiple things are there, right? If one of them is true, it'll automatically terminate early because it knows if A is true, overall everything is true. So there's no even need to evaluate the rest. Does that make sense? And if A is false here, overall everything is false. So there's no need to evaluate the rest here. So this is a trick people sometimes use. Like if you want to be safe about how you do something, you can say something like if length of S is greater than 0. And remember, because Python does things like in a false array, right? If I just do if len of S, that automatically means len of S is greater than 0, right? Because if it returns 0, this would be false. So if len of S and S of 0, right? This is a safe statement to evaluate because if S was an empty string, if S had nothing in it, then this would return false and this would terminate early. So I would never even try to index into the 0th element of S. Does that make sense to people? Cool. Okay. So that's what happens here, and that's why I'm pointing it out. Like if you start off with race cars and already the R and S don't match, we're not evaluating the rest of these recursive calls. We just immediately terminate early and we say false. Right. If I switched the order though, if I did something like this is unfortunate because now it's not going to terminate until it reaches the very like last base case and then it works its way up, right? So there's no way I can terminate early. So does that make sense how just the order of how I put this stuff in my if statement allows me to kind of make less calls in the case of this not being a palindrome? Okay, nice. Trying to think what other questions do we want to go through, or should we get started on homework? I want to go through search, but I'm worried that there's not enough time for that. So why don't we just go to the homework that I already have ready? And let me share that on Google Classroom. In the meantime, why don't you guys take another 5-minute break and we can reconvene at 9:25. I am once again having issues sharing things on Google Classroom. So hopefully my sister will be able to share the homework with you all soon enough. In the meantime, I want to leave you guys with a thought while we're waiting for a few minutes. If I have a list of items, right? And remember, we're in the world of code, not just, like organizing things in our room. How do I organize it efficiently? What's a good way for me to be able to sort a list of numbers in numerically like ascending order, for example?
You could do like a filter thing with a for loop, and you could take a list of numbers and put it into a new list and have it go up by like least to greatest.
So the way let's break this down step by step. So you're saying let's keep on going over our list, right? And so first we identify what the smallest item is, smallest element, right? Then the second smallest element, the third small, right? And we could keep going over that list, right? And
So it'll
so
take a lot of computation power though for like really large lists.
sure. But okay, you have the solution. So we have, let's say, a list of n items, right? How many times do we have to go over that list in order to figure out the, smallest, then the second smallest, third smallest, and then the largest element all the way? How many times? Let's say we had 100 elements, right? So I've been saying n times. Would you agree, Jacob? So if we have n elements, we have to go over it one time to figure out the first smallest element, then this another time for the second small, right? So, oh, my sister shared the homework with you guys. So yes, you guys can open it up on Google Classroom, please. And basically, if we don't finish its homework, but also if we, I don't know, can work through it in class, that is, then we're done. Then there's no homework. So, okay, so it's not a bad idea, Jacob, and it works. It's going to take a while though, because we're going over the list n times, and there's n elements in the list, right? So now how many elements are we looking at total?
You're looking at like an exponential amount greater because you have to look at every single element a bunch of times.
Is it exponential?
Well, no, it's like n times n or something like that.
Yeah. Quadratic, n squared. That's not exponential. It's fine. It's not that bad. It's n squared is actually it's
That's
perfect.
still exponential though.
It's still
squared is exponential.
so exponential we would say is 2 to the n power. N squared is quadratic, right? That's but yeah, I know what you mean. There's an exponent in there, but yeah. Okay, sure. So do people have the homework up from Google Classroom? Okay, nice. Do I have it? I don't know if I have it. Okay, well, why can't I access it? Okay, that's fine. I'll just make a copy. So I think, Evan, you've been doing a great job of contributing. But I want to make sure people aren't just being like, hey, we'll just wait for Evan to tell us what he's thinking. So I want other people, I want to see if they know what to do for this first thing. Is this the right window that I'm sharing? Yes. Okay, cool. So what do you guys think about this problem? First of all, is this even English? Yes, it is. But what is this asking? Okay, so given a length n, string s. So the string is called s. It's of length n. By the way, these are all actual problems chosen from actual competitions, right? I think one of these, or maybe that's on tomorrow's homework. But there's going to be a USACO problem very soon. So these are competition. These are chosen from some of the competitions I mentioned in class on Monday that are out there for like anyone to participate in. So okay, so given a length n string s, calculate different arrays a sub 0, a sub 1, blah blah blah, a sub n minus 1 as follows. A sub I is the LCP, the longest common prefix of S and S dot substring I. So okay, I think this is a very, very poorly phrased problem, but this is the original phrasing of the problem. This is not my problem, okay? So what is this saying? Let me try to zoom out so you can see more of it. Okay. So A sub I is the longest common prefix of S and S dot substring I. So what it's saying is, hey, if you start a substring of the string that starts from the 0th character or the first character or the second character or the third character, right? This S dot subster, by the way, does not exist in Python, this kind of notation, but basically what it means, the equivalent of this in Python would be this. Let's go from the ith character to the end of the list. Does that make sense? I think this is how they do it in like JavaScript. So maybe this is something Jacob's familiar with, but S and S dot subster I, right? What is the longest common prefix of this? So if start with I equal to 0, right? That's just S of 0 all the way to the end of the list. So that's just S, right? Now, what is the longest common prefix that S has in common with S? Well, it's the whole string, right? Every single character is the same. 1, 2, 3, 4, 5, 6, 7. Okay. But now let's say, okay, I is 1, right? We're starting from the first character all the way to the end of the list. So now our string looks something like this, and S is still A, B, C, B, C, B, A, right? What is the longest common starting prefix they have? Well, it's 0, right? They don't have any letters in common. 2, same thing, no letters in common from the start. If we're looking from the start, no letters in common for 3, no letters in common, no letters in common. Oh, now we have a single letter in common, right? This A matches up with this A. Does that make sense? Okay, so let me give you another example beyond what they have here. Let's say we have S is equal to ABC, ABC, right? Oops. Oh no, what's going on? Okay, or you know what? Let's just make it fancier. Okay, so now let's compare that to S of 0 to the end, right? Well, the whole string is going to be in common with itself, right? So all 10 characters will match up with itself. Now let's say we have S1. That's equal to this. Well, this letter matches up with the first letter of this, right? So the longest common prefix is 1. How about 2 here? What's the longest common prefix? Nothing. I see Minu shaking her head. That's a 0. Okay, great. How about this? What's the longest common prefix? 0. I see a goose egg from Evan. Okay. What's the longest common prefix for these two? Sorry, these two. I see. I'm hoping that's not a 0 from Anirudh for this one. I see some 3s. So that looks like a 3 to me. Why? The A, and B match up. Okay. Great. How about this? Oops. 1. Thank you, Anirudh. Yes. This is a 0, right? This is 1. Yeah. So you guys get the point, right? Okay. So how does this work? What is this saying? Like, hey, figure out what the array is, right? And this is the array. A is the array 1. And each element in this array, right? It's basically saying like, hey, if I were to take a substring of the string starting at index I and compare it with the original string, how many characters do they have in common? What is the longest common prefix? And I've mentioned to you before how like speed is a big part of these things and efficiency, and like there'll be, you know, maybe you run this over a small input and you check, hey, it works. But then the question is, does it work over a really, really, really huge string? So in this case, 5 times 10 to the 5th power is the maximum length of the string, right? That's 500,000 characters. How are we going to solve this problem? Any ideas? Any thoughts? Any thoughts from, I think Minu. Let's start with Minu.
I was thinking just to first create like a general function for comparing two strings, and then calling that function in a bigger function that just does the overall task of um, looking at each substring.
Wait, sorry. So compare substrings and then what should we call it? Like main or something?
Yeah.
Now, there is definitely some self-similarity to this, Anirudh, but it remains to be seen whether that means that we need to use recursion or not, or whether, I mean, you never necessarily need to use recursion. Sometimes you do, but not in any of the problems we saw today. You didn't need to use recursion, but we'll see. So I like though this design kind of blocking different tasks into different parts instead of having one mega function to rule them all, right? We have functions that do like individual tasks. So compare substrings is its own thing. Okay. Why don't we start with compare substrings? Help us implement this, Mino. What inputs does it take?
So you're gonna have string 1, string 2.
Okay. String 1, string 2. Great.
And then you would have a count variable. So set count equals 0. So for I in S1, if if uh, sorry, let me think about that.
So let's define some of the challenges out loud here. So we want to be able to compare each character at the same position for both strings at the same time. Now, do we know if both strings are the same length?
No, we don't.
Yeah, they're almost definitely not. Only in the first case, when both of the strings are
So
identical.
you'd want the minimum length, right? So if we call S2 the smallest character, then we can say for I in range 0 to length of S2.
Nice. Okay. And by the way, do people know why like Minu is assuming that S2 is going to be the smaller of the two strings, or at least equivalent in size? So she's defining S1 here to be the original string, right? And S2 will be basically the perhaps truncated string. So it'll be the substring. Okay, great. So this is nice. So we only have to worry about S2 ever getting smaller than S1. And so this should be where our bound is defined. Great. Okay. So
So then you would do if S2 of I is equal to S1 of I.
if SI1
Yes.
S1I equals to S2I. Right.
Count plus equals 1.
Count plus equals 1. Okay.
Else break, right? Because you don't want to.
Nice. So do people agree with this? Will this help us figure out if we have two strings, what is the longest common prefix of the two? No. Okay. Yes. So find LCP. Let's actually rename define LCP. Okay, great. Wait, Evan, you have a question? Are you raising your hand? Oh no, okay. Everything's good. Oh, I see a thumbs up. Okay, cool. Nice. So now we have find LCP. Great. Now what should my main function be? Anirudh, why don't you help us with this?
Probably I like the input string or so.
Let's you take the initial string. Sure. Yes. Great. And now what should we do with this?
Probably call the function on the string.
Okay. Is that it?
Probably you should find like probably make a variable for like the length of the string.
For the length of the string. Okay, so let's say. Good.
And then probably like for the find LCP function, put like s and then len s for s2, I think. I'm not sure. Actually, no, that won't work because it's a integer. Uh,
One thing I'll mention is there's something in Python called type hinting. So you can actually say like, hey, if people need to figure out what kind of type this is that this can take in, this takes in a string, this takes in a string. And so let me just add in some type hints so we know what this all is. So this takes in a string, this takes in two strings, right? If we even want to be fancier, we can add in maybe like a multi-line comment, be professional. So find LTP takes the original string S1. We could even rename our variables to be better. So we can say something like original string. And then we can say substring. Okay. Cool. So, and you know what? Let's just let's see. Okay, so len of s is a number, right? It doesn't make sense to add a number here, right? What should we do? It is helpful.
probably you can define the substring as one of the indices of the original string.
Substring. This is the original string.
Like if it's like A, B, C, D, like you can do like you can take A as the first one, like, and that's your sub. You can make a. I'm not sure if I want to make too many variables, but like probably like a variable for like the substring, like a temporary variable.
Okay, sure. Let's say substring equals, and then how do I define it?
Uh, I think string S of like 0, or like the original string 0.
This?
Yeah.
Okay. Nice. And then you're saying pass in the substring here. Yeah.
Yeah.
Okay. I mean, this is on the right path, but let's remember what is the problem asking for? It wants us to give this array. Now, I don't really care about the list, arrays, data structures. We're ignoring data structures right now. I just want maybe to print out the longest common prefix at each step, right? How do we iterate through these steps though? How do we iterate through all of the possible values for I, right? That's I gives us, each of these indices. I is basically like everything from 0 to the end of the list, right? It's all those possible indexes. There's those indices. How do I iterate through all the possible like substrings I can get from starting at the start, going to the end, then starting at index 1, going to the end, index 2 to the end, right? How do I do that? This is hard coding index 0 to the end, but I want to say, hey, iterate through any possible starting position, right? All the possible starting.
Maybe make the ending index a variable and possibly a counter also that goes up.
So the ending is always going to be the end of the string, right? If you remember our example with, maybe I shouldn't have deleted that, but S is A, B, C, B, B, C, B, A, right? So then the substring was either the same or this same thing minus the first letter, or the same thing without the second letter as well, right? These were our possible options for the substring. So we just keep iterating through the entire string S, and we keep lopping off one letter at a time.
Probably just instead of a 0, you could probably make the beginning probably a variable and a loop.
Yes.
That's mine.
Okay. What does the loop look like?
It's pretty similar to like the find LCP one for I in range. The increases after every loop. So
Yeah. What should the range be?
probably the string length.
So len s.
Yeah.
And this 0 is kind of unnecessary, right? Because that's implied if I don't put it. So let's do that. And then here you're saying for IDX in range len s, right? Let's do this. Yeah. And maybe we don't need a separate variable for this. Let me just put it directly in here. Let me just clean it up by saying, let's call this original string. This is original string. This is the I position, right? Okay, so now the substring, yes, great. We're truncating, you're starting from the second 0th position, the first position, the second position, right? So on and so forth. Then we call find LCP on S and the substring. What do we do with this value once we have it?
Print it out or in a list.
Yeah, we can add it to a list, but let's not worry about lists until tomorrow. So let's just print it. Sure. Great. What is this returning? What does find LCP return?
It returns I think it returns the value, like the array, like what you're supposed to print out, but it doesn't print it out.
Well, yeah, right now it's not printing anything out. It's not returning any specific variable. So by default, if you try to get the value from a function that's not returning anything, it returns none. Or even if the function returns something in some cases, but not in other cases, then it returns none, right? So right now the function returns none. So what should we do, Minu, to fix find LCP so that it returns what we want?
At the very after outside the for loop, you have to return count.
Great. So we can return count here. Another option, if we're just printing the answer, we could have just printed it directly inside of here. But I think it's always nice to have functions that return count. Let the caller of the function decide what they want to do with that value. In this case, we want to print it out. So now we have these functions. Actually, so inside of a programming competition, they'll have some kind of starting boilerplate code for you, like a main function that will take in the inputs that they expect, and then you kind of start implementing this part and this part, right? I don't want to actually call or create a main function because main has a specific purpose in Python, which is just like, okay, if a file has a main function and you execute that file, it will just run that file. We're inside a notebook, so we don't have to use that main function notation. It doesn't really matter. But I'm just gonna rename it just so that we kind of have a clearer name for this function and say, okay, find LCP array. Or let's call it like print LCP array or something like that. And you know what else we can do? We can use Jacob's trick from earlier where he took the ending and instead of making it a /n, he made it a space. So we just put a space after everything. Okay. So now let's check if this works by testing out with the test case that they themselves gave us. So that is ABC, BC, BA. S is not defined, yes, because I renamed part of it. So let me rename, okay, all the variables. And whoa, our solution matches this exactly. Looks good, right? I mean, we can try some other things. Any other suggestions people have for strings to try out? No, okay, no one wants to try out any other cases. Fine, I get it. We're perfect. We're on top. Okay, no, okay, this is, I think, a pretty good solution, and that's nice. I mean, who thought when you saw this, right? Did you guys think that you could figure out the code in like, I don't know, what is that, 10, 15 minutes? Maybe 20 minutes, I don't know. That's pretty impressive. This is like 19 lines of code, and boom. We have not only the solution, but also a test case. Very nice. Okay.
Wait, sorry, out of curiosity, what is the most efficient way to solve that?
This is, I'll go through it a bit more tomorrow, but this is basically the most efficient way to solve it because there is no basically guarantee, like there's no, you have to calculate the longest common prefix separately for every single character, because there's no relation between the longest common prefix for like substrings starting at character 0 to a substring starting at character 1. So this essentially is the most the quickest way to solve this problem. Yeah. So this is an optimal solution. And I thought I had put which competition this was from, but I think it's somewhere in my notes, but not in here because I didn't want people looking at it. I'll find it tomorrow and let you guys know. But yeah, basically this is a actual competition problem, and I think this is the most efficient solution. Yes. Nice. Okay. So one hot summer day, Pete and his friend Billy decided to buy water. Oh, if you want maybe like a slightly more actually, you know what? No, this is elegant. This is pretty good. No, it's not. There's a zip function that I'll teach you guys later. Basically, or I'll teach you right now. But basically, what it'll do is it will take two things and map them up as far as you can go. So, like if I have something like 1, 2, 3, and I zip it together with 4, 5, 6. So let's say I do 1, 2, 3, 4, 5, 6. It will pair each letter up in the corresponding positions, or each character up in the corresponding position. So 1 and 4 will get paired together, 2 and 5, 3 and 6. Right. And so maybe like you might want to iterate over this list in order to compare like the character at corresponding positions. But what's inefficient about this is that now you've done some operation that goes through the whole string. Whereas here, what Minu said in her code, I mean, it just terminates early if we find that there's not a match. So this is a bunch of wasted effort if, you know, none of your characters match, to try to pair them up in a more elegant solution. So this is, I think this is actually more clear what it's going on, and also like it allows us to terminate early, which is always nice. Okay. So one hot summer day, Pete and his friend Billy decided to buy a watermelon. They chose the biggest and the ripest one, in their opinion. After that, the watermelon was weighed and the scale showed W kilos. They rushed home dying of thirst and decided to divide the berry. It turned from a watermelon into a berry. I don't understand how this works. Pete, however, they faced a hard problem. Pete and Billy are great fans of even numbers. That's why they want to divide the watermelon in such a way that each of the two parts weigh even numbers of kilos. At the same time, it is not obligatory that the parts are equal. The boys are extremely tired and want to start their meal as soon as possible. That's why you should help them and find out if they can divide the watermelon in the way they want. For sure, each of them should get a part of positive weight.
Wait, so you just need each half to be, or not even half, just each part needs to be an even number?
Yep.
So you just need W to be an even number?
Yep.
And it has to be integers, like can't be decimals?
That's right.
Oh, okay.
You want to call this one first, Jacob?
No, I'm gonna let Evan take this one.
Come on. You basically led us to the solution. Just say it.
So I would say like just take the input of W,
Mhm.
and then just like divide it, I guess, and then put each result mod 2. Should be, and you should go until the mod reaches both of them having 0.
Wait, sorry. Explain this again.
So it's like you would well, first you check if W mod 2, because if not, then it's just not gonna work.
So if this is equal to
0.
0, then that's good, right?
Yeah. And then
All right, let's look at this. Okay, for now, let's just. Oh, come on! Why do I keep this?
wait, was there any specification of how they cut it?
No. They're hungry. Just give them some food. Come on.
So I'm blanking here. So they would cut it in half so that both are even.
Okay.
I guess like if it's mod 2, then like you would put a nested conditional.
Nested conditional. Okay. So what are you saying? If Pete percent 2?
No,
equals
so if it's like if W percent 2, then you continue and you say like
Oh,
Pete equals W over 2 and Billy equals W over 2.
okay, sure.
I don't even know how to nest it. That'd be fun.
But yeah, we can nest the statement. Sure, that's fine.
That should be it. Unless I misunderstood the problem.
Well, we don't.
Where they said it doesn't have to be half, right?
Wait, they want the weight to be an even number. So if you divide 50 by 2, you're going to get 25, and that's odd.
Yep. Now,
They don't have to be equal, right?
they don't have to be equal. Correct. Exactly.
Just subtract 1 and then add 1 to the other.
Okay. Is this what we're doing? Okay. Now, let's read the question carefully because it's very poorly written. Again, not my question. This is an actual competition question. Can they divide the watermelon in the way they want? That's all the question is asking. They're not even asking you, hey, what should we give to each person? They're just asking you, can you divide it in the way that you want? So, what does that mean? The answer is just basically a Boolean, right? True or false. Okay. Now, what I like to do, now that we know about functions, let's just put this into a function. Okay. And W is an int. And we can reuse some of this, right? Maybe. But let's say this. If W percent 2 is equal to 1, right? Then we just say return false, right? Let's just terminate early. Let's just return so that we don't even have to worry about the odd number persisting, right? It's gone, right? In fact, I don't even need the equals 1, right? Because if this equals 0, right? Then that will return false. W percent 2 will return 0. That's a falsy value. This will return false. W percent 2 is 1, great. Then it returns false. Okay, so odd numbers, not allowed. This is an even numbers club only. Great. Now, we have all of this here. Do we need any of this? Do we care how much Pete or Billy get? No, we just care that there is some kind of number that we can give to each of Pete and Billy. And then if there is, then we return true, right? So is there anything we have to do to just return true right now? I mean, we're already determined that there's an even number for the weight of the watermelon.
Wait, why are you subtracting 1 and adding 1?
This was Minu's suggestion because if we just do W divided by 2, that's 25. And 25 is odd. And she said if we subtract 1 here, Pete gets 24, Billy gets 26. Now, that works, Minu. But now let's say W is 52. Well, then
what if it's like 48, then it's 23 and 25, and neither gets even.
Exactly. So we could do two things. One is we could, if we wanted to actually come up with a distribution for something that they can get.
But couldn't you just do a mod 4 so that it's always even? So it's like 48, you would get like true, but 50, it would be false because even if you cut it in half, it's not evens.
Well,
Wait, but do we even need to do all of that? We know that if it's an even number, there's always going to be a way to get an even weight, right? Unless I'm wrong.
Why can't we just let them slice it themselves?
I like this. We should create.
Yeah, why just give one person two? You know,
Unless it's 2. Like if you have 2.
you can give someone
That's-
two and you give
So
anything but 2 works.
Yeah. anything but.
Even number besides 2.
Okay, excellent. So yes, why don't we end class right here? But basically, here's the thing. If we want to figure out exactly how much Pete and Billy get, it's probably one of these two numbers is an optimal distribution and will result in an odd or even number. But we don't actually care how much they get as long as they get an even number each. So we've already determined that we know that, okay, if they both get even numbers, an even number plus an even number will be an even number, right? Thus, W must be even for them to each get an even number. However, that doesn't mean that W being even makes that each of them get an even number. So if there's only 2 pounds of watermelon, that means Pete and Billy, if they're dividing it and each gets a non-zero amount, each one gets 1. That's odd. That doesn't work. But if we have 4 pounds of watermelon or 4 kilos of watermelon, each one gets 2, that works. If we have 6 kilos of watermelon, if each one gets 3, that doesn't work. But if one gets 2, one gets 4, that works, right? So for every even number besides 2, basically, we can give 2 kilos to one of them and that W minus 2 to the other one, right? That should always work, right? As long as we want to give each one both of even number, and this will always be an even number, W minus 2, as long as W is even. We know W is even because if it were odd, it would have returned already. So if we've got to this point of the function, W is even. However, we need to make sure W minus 2 is not 0. If W is 2, it won't work. So if we can also add another condition, we can also slap it onto our earlier if condition, but maybe it's nicer to have our code like this, cleaner, so we can see the different conditions. Return false, and then return true, right? Does this make sense? Okay, so it's 10:02. It's a bit past class time. I will end the live stream, but you guys all have the